Stephen Goldman. He has a bachelor's degree in physics from Polytechnic University of New York and an MA and PhD in philosophy from Boston University. Since 1977, he's been the Andrew W. Mellon Distinguished Professor in Humanities at Lehigh University, which is a joint appointment in the departments of philosophy and history. His research focus is on the history, philosophy, and social relations of modern science and technology. And in an earlier position at Pennsylvania State University, he was the co-founder of one of the first U.S. academic programs in science, technology, and society studies. He's published numerous articles and books on the emerging forces impacting relationships between knowledge, innovation, and global commerce, and is the author of courses for the Teaching Company, including Great Scientific Ideas That Change the World. So please help me welcome Dr. Stephen Goldman.
Thank you very much, and good evening. But whatever else you do, don't switch from being a science major to a philosophy major, or anything, or from any other subjects, as a matter of fact, without checking the career opportunities that are available in philosophy, or the absence of career opportunities. As you can tell from what Terry said at the beginning about what I've been doing the last 3 days here in Portland, I am not unionized. What I want to talk about this evening is the nature of scientific knowledge. So the focus of this talk is not on what scientists know. I'm not going to talk about the wonderful theories that we have about the universe, about matter and energy, about life on Earth, but what they know. The focus is on the word know, and to try to explain, to some extent at least, in what sense scientists claim to know things and how they come to know what it is that they know. What it is that they know is secondary to the claim that they know it. Lots of people have opinions and beliefs. We don't really get as agitated about people's opinions and beliefs. We understand that they are not universal, as we do when scientists claim to know things that make us uncomfortable, but they claim that what they know is universal and that it's true in some special sense. So scientific knowledge is important to us, especially in our society, because after World War II, science has been empowered to be a very important public force with massive public support for funding, and it's been incorporated into the whole structure of the university, the education system, our political policies, and of course, through technology, it affects the way we live at a very intimate level. So scientific knowledge, I want to say, I'm going to be describing, poses a problem. Knowledge generally poses a problem that people are not always sensitive to, and I'm going to be talking about that. I want to talk about what scientific knowledge clearly is, what it equally clearly is not, and what difference it makes that we know more clearly the nature of scientific knowledge. The knowledge problem that I'm going to be talking about is an old problem, and it's a very deep problem. It's not a problem that's going to go away soon, because people have been agitating over this problem for at least 2,300 years that we know of. This problem was internalized by modern science. Modern science internalized a problem that was left unresolved in ancient Greece, and it causes science to have a kind of a split character with respect to claims that scientists make to have knowledge. For example, to claim that the theory of relativity is true, that the theory of evolution is true, and even when they claim to make statements about what they know about the atmosphere in terms of the nature of global warming, for example. So that's kind of a look ahead at where I'm going. That's where we're going to be in terms of the course of the lecture that's going to unfold now. Scientific knowledge poses a problem, and what that problem is, why that's just an instance of a more general problem about claiming to know things. What I'm going to be talking about, what scientific knowledge clearly is, what it isn't, what difference it makes, why this problem is old and deep, how it was internalized at the rise of modern science. And the conclusions that I'm going to reach, so just in case you like to know in advance what you're going to be hearing, the conclusion that I want to reach about the nature of scientific knowledge is to hopefully convince you that it is at least arguably the case that scientific knowledge is inescapably conjectural. That is to say, scientific knowledge is always dependent on assumptions that cannot themselves be proven to be true. So it's conjectural. The power of science, the fact that it is a powerful source of ability to understand, to explain natural phenomena, and to give us technological control over natural phenomena, does not in any way conflict with the fact that scientific knowledge claims are based on conjectured assumptions. And my second point will be that scientific knowledge is historical, that scientific theories evolve over time, and because the assumptions that they make have to be qualified. That science really is an evolving account of experience, not a picture of reality. Very often the rhetoric of science leads scientists to speak as if scientific theories at any given time give us an accurate picture of reality. I'm going to be arguing that the nature of the problem that knowledge poses, as it was internalized into modern science, leads us to have to conclude that scientific theories are not pictures of reality, but they are instead accounts of experience, powerful accounts of experience, our best accounts of experience, but not pictures of reality. Okay, that's sort of the preliminary. I've telegraphed the ending, but the important thing is how we get to the ending, not the conclusion itself. Scientific knowledge, I claim, poses a problem. Well, there are two aspects to this problem. There's the sort of superficial aspect of the problem and the deep aspect of the problem. The superficial aspect of the problem is that, very surprisingly, considering the noble role that was given to science in America after World War II, science was given tremendous credit after the war by the media and by scientists themselves, of course, for having played a key role in winning the war. Not merely the atomic bomb, of course, but the development of the ability to manufacture and distribute penicillin cheaply. That was a major factor in winning the war. Radar and all sorts of electronic countermeasures and lots of weapon systems that scientists developed quite independently of the atomic bomb. And then, of course, you add the atomic bomb to the mix, and it does seem as if this World War II, on our side at least, was the scientists' war. And in the wake of World War II, science was funded by the federal government to a degree that was totally unprecedented in American political history. Until World War II, science was not funded by the federal government almost at all. Hard to believe now when we casually spend tens and tens of billions of dollars a year to fund scientific research. But prior to World War II, effectively the only money that the federal government gave for scientific research was for medical research. The war on cancer starting in the late 1930s, and at the end of the 19th century, funding laboratories that studied epidemic diseases because of the fear that the flood of immigrants that was coming into the country between 1880, let's say, and 1923, when the immigration laws were toughened, would be bringing diseases that we needed to be protected from. Apart from that, if you wanted to build an instrument, an expensive instrument to study the heavens, for example, a major telescope, well, you had to find a rich person to do it. The Carnegies and the Rockefellers funded the building of the 100-inch telescope and the 200-inch telescope in Southern California that between 1919 and the 1960s were the world's finest telescopic instruments, actually really into the 1980s, before a new generation of telescopes was built. And even then, the Keck telescope in Hawaii is also privately funded. There was effectively no federal funding, but from 1945 until the present, the involvement of the federal government in scientific research, in funding scientific research, gave science a whole new status in society. And we were very proud of that status. In spite of that, beginning in the 1960s, there began a sustained critique of science in America, and more generally in Western Europe, that culminated in the mid-1990s in what was called the science wars. The war was between the natural science community on one side and the social science community and humanistic intellectuals on the other side. In the beginning, it began in the 1960s with a very unexpected and sharp critique of the concept of objective knowledge, which had been taken for granted for centuries, that science is a form of objective knowledge. But in the 1960s, an intellectual movement arose that argued that there was no such thing as objective knowledge and that science was not truly objective, that scientists incorporated into their work value judgments that were subjective, and that therefore it was deceptive to claim that scientific knowledge was deceptive. And I would have to say that between 1960 and the 1980s, this critique won a very large measure of support in the intellectual communities in Western Europe and the United States. Further, science was attacked in the 1960s and 70s as being highly politicized. This was part of the whole movement of the time, the critique in the 1960s and 70s of establishment institutions generally, not just the Vietnam War, but those of you who are old enough to remember back then, there were mass demonstrations against multinational corporations. There were mass demonstrations on behalf of the environment. There was the consumerist movement, and science and technology were criticized in the 60s and 70s as having been co-opted by political agencies like the federal government, that scientists and technologists were sort of in the pay of federal and corporate agencies that led them to do the research that they did, and that they were in some sense responsible for the military and anti-environmental actions in society. That was a political critique of science. And then, perhaps even more surprisingly, in the 1980s and early 1990s, and although it's quieted a bit, it's still around, there was suddenly a revival of, it's almost as if the Scope trial came back to life, and we had a religious attack from the religious right, an attack on society, on science, that science was not the only road to truth, and that scientific theories needed to share their airtime, especially in the elementary and high schools, with religious teachings, which were equally plausible, because after all, science is not absolute truth, it is a highly educated opinion. So if you put those three factors together, by the 1980s and early 1990s, there was in place in Western Europe and the United States something like a war, and it was actually called Science Wars, which peaked in 1996 when a social studies journal published an article by a New York University physicist named Alan Sokal, who wanted to show the intellectual corruptness of this critique of science, and he published in this journal, which was notorious for being a platform for sociological critics of science and of the concept of objective knowledge, he published an article that was ostensibly about physics by an important physicist, but was true gobbledygook. And he was so confident that these people would be so thrilled to have a physicist defending their critique of science that they would publish it without sending it out for review, so that they would not know that it was gobbledygook. And then he timed it so that he knew when the issue was going to be published. It was in the spring of 1996, and he timed it so that in another journal that typically humanities people read, he informed the editor that this was a hoax. So it's called the Sokal hoax, and it made a big noise in 1996. The scientific community was thrilled, and their laughter could be heard from one end of the country to the other, and the humanities and philosophical and sociological people were supposed to be abashed by this because, after all, it was total nonsense, and yet it had been proudly published in a prominent journal. The response to that, strangely enough, the response to that hoax was very mixed, with quite a number of scientists actually defending the journal, claiming that, it was a trick and it was not a nice thing to do, and how could they possibly be expected to understand that the language he was using was nonsense to a physicist? And in fact, there was one physicist who published in Physics Today an article showing that there were actually sentences written by prominent architects of quantum mechanics in the 1920s and 30s, which didn't sound any less gobbledygooky than what this guy had published. Now, for some reason or other, the science wars peaked then, I don't know why, people maybe just got fed up with the whole thing, and it waned, except of course for the creationist and the intelligent design lawsuits. But that is what I call the superficial scientific knowledge problem. That is the most visible, and it made a lot of noise for a while, problem with scientific knowledge. The response of people in our society, the negative response of people in our society to the claim that science alone is knowledge. After all, the word comes from a Latin word that means knowledge. Science is knowledge. Anybody who claims to have knowledge either has to live up to the criteria of what scientists call knowledge, or it's just not knowledge, it's opinion or belief. So that brings us to the real scientific knowledge problem, and that is because the scientific knowledge problem is one expression of the knowledge problem generally. And that problem is very deep because it goes back to what most of us don't like to have to do, and that is to look at the meanings of words. What does the word know mean? What do we mean by know? How does knowledge, the word knowledge, differ from opinion, from belief, from know-how? How are we supposed to decide what constitutes knowledge, what constitutes opinion, what constitutes belief? And by the way, what is the relationship between knowledge and know-how? If what scientists have, if what philosophers claim to have is knowledge, how does that differ from the kinds of things that people say that the philosophers and the scientists say, oh, that's not knowledge, that's opinion, that's belief, or that's just know-how, but it doesn't qualify as knowledge? Now, what makes this problem deep is that where would you go to solve this problem? Where do you go when you want to find out what the meaning of a word is? Well, normally we go to the dictionary. But the dictionary is just a compilation of how other people have used those words. There is no dictionary that tells you the correct meaning of a word like truth or justice or knowledge. There is no absolute dictionary. Every word means what some group of people have decided to use that word to mean. And so if you ask what does knowledge mean, you have to go back to why do we use it to mean what we mean it, how do we use that word and why do we use it in that particular way? So I want to highlight the source of the knowledge problem in Western culture. And it emerged 2,350 years ago, roughly speaking, in a rather vicious battle between Plato and later his student Aristotle and the other Greeks who were considered philosophers in ancient Greece. They were called the Sophists. Plato hated the Sophists. And in a number of his dialogues, in quite a large number of his dialogues, he makes quite vicious fun of the Sophists and depicts them as charlatans, as not worthy of the name philosopher, as teachers who for a fee will teach people anything in order to make sure that they get their fee. And in particular, were intellectually clever people who used their intelligence to teach people tricks, how to win arguments even when they were on the losing side of the argument. Which is why, because of Plato's influence, the word sophist today is used as a negative term. When we want to say that when we call someone a sophist, we mean that they are tricky. We mean that they are using arguments and logic in a deceptive way in order to make us agree with conclusions that in fact do not follow logically and are not correct. So Plato had a particular agenda, and Plato argued, and was picked up in this by his student Aristotle, that the word knowledge means that about which we cannot be wrong. Opinion and belief is totally different from knowledge, according to Plato. Opinion and belief is that about which we can be wrong, whereas knowledge is that about which we cannot be wrong. Knowledge is, as far as Plato is concerned, fundamentally different from know-how. Know-how is what craftsmen possess. They know how to do things. They know how to do things. The farmers know how to grow crops and to breed animals, and metalsmiths know how to make shields, and shoemakers know how to make shoes. Plato gives all of these illustrations. Horse trainers know how to train horses. They don't understand what they're doing. They just get the results that people are willing to pay for, and so that is not worthy of being called knowledge. This was Plato's position. And for Plato, given this particular notion of knowledge, knowledge is universal, it is necessary, and it is certain. That's because we can't be wrong about it. In order for us to say anything about which we could not be wrong, it has to be something that is universally true, necessarily true, and 100% certain. It also means that the object of knowledge is timeless. It can't change over time because it's universal. Is there any example of this? We could ask Plato. You could define words to mean anything you want, but that doesn't mean that there's anything in the world that corresponds to it. But Plato said, yes, there is something in the world that corresponds to knowledge, that meets all of these conditions, and it is mathematics. It is geometry and arithmetic. The truths of geometry and arithmetic are timeless. The sum of the interior angles of a Euclidean triangle, he would not have said Euclidean because Euclid wrote his book, The Elements of Geometry, after Plato died, but the sum of the interior angles of a triangle, he would have said, is 180 degrees forever, everywhere in the universe. It doesn't matter what your race, color, creed, religious, or political beliefs are, whoever you're going to vote for in the general election, it is the case that the sum of the interior angles of a triangle is 180 degrees, and that never changes. Now, 2 plus 2 is 4 everywhere and for everyone forever. So Plato said, we have an example of a body of truths that meet my criteria for knowledge. Why should we settle for less in any other area? If you want to claim that you have knowledge about nature, if you want to claim that you have knowledge about which is the best political system, if you have knowledge of what is morally right and morally wrong, then you should have to meet these same criteria. What you claim to be true has to be shown by you to be universal, necessary, certain, and timeless. Oh, these are tough criteria. Along come the sophists. Now, they were there before Plato. The sophists, on the other hand, took a very much more, what you might call, human perspective, and they claimed that knowledge, that the word knowledge, refers to, effectively, know-how. That knowledge for the sophists is a matter of context. That every claim that we make that something is true has to be understood in a particular context. So knowledge is contextual. It is contingent, according to the sophists. It's contingent. That means it's dependent on some kind of assumptions. If you don't share a person's assumptions, you're not going to share the conclusions that they reach by way of reasoning. And according to the sophists, knowledge is only probable. We can never be 100% certain of any statement we make about anything outside the human mind. As for mathematics, the sophists said, of course we can achieve certainty in mathematics because we make it up. We define what a circle is, so big deal that all of the properties of the circle are deductively certain because you can look them up in geometry. An angle inscribed in a semicircle must be a right angle. Why can't you cheat a little bit and make it a little bigger or a little smaller? It can't be done given the definitions in Euclid's Elements of Geometry. It's the same thing with chess. It's the same thing with any game. Once you agree to the rules, then the moves in a game can be known with certainty to be legal or illegal moves. Nobody's amazed at that. Nobody thinks that this should be the basis for an approach to the world. That's the way the sophists responded to Plato's argument. So for the sophists, knowledge and its object, whatever it is we're talking about, the object of knowledge, and we're really talking about knowledge claims about some things outside the mind, not games that we make up. Knowledge is historical. It means it changes over time. It's not timeless. And knowledge claims are relative. They're always relative to a particular context in which that knowledge claim is made. If the context changes, the knowledge claim changes. So what is true in one context may be false in another context, because in that second context, there are different assumptions that are made, or there may be different facts that are relevant. And so for them, knowledge is fundamentally historical. Let me jump ahead anachronistically and point out that consider, for example, Plato hated the idea that anyone could take seriously the notion that something could be true in Athens and false in Sparta, true in the 4th century BCE and false in the 2nd century BCE. But just to take one example, and we'll get into this a little bit more later, we can take an example from science itself. Newtonian mechanics was thought to be true from, roughly speaking, 1700 until 1905. But after Einstein published the special and general theories of relativity in 1905 and 1915, then we don't consider Newtonian mechanics to be true anymore. See, the context changed, the assumptions that physicists were willing to make about the behavior of matter and energy changed, and then all of a sudden, without any disrespect to Newton, we still genuflect whenever we pass by his bust, but we do not think that Newtonian mechanics is true. It is still useful, but we don't believe that it's true. So that would be, from the point of view of the sophists, that would be a good illustration of the sophistic definition of knowledge. The important thing here is that here we had two different definitions of the word knowledge. It's not that one or the other of these is right, because there's no such thing as a right definition of the word knowledge. It is a fact about Western culture that ever since Plato, ever since this battle, which is depicted at one point in one of Plato's dialogues, a short dialogue called The Sophist, which is his most, well, maybe one of the most vicious attacks on the sophists, and the conclusion of that little dialogue is that sophists are not philosophers. He talks about a battle that rages between the sky gods and the earth giants. The sky gods are Plato and his students, who are defending a noble conception of knowledge that is worthy of an elite human being. And the sophists, who are the earth giants, who defend a mean-spirited notion of knowledge, that it's contextual and relative and historical, and it can be different in Athens and different in Sparta. So this battle was effectively won decisively by Plato and Aristotle. And for 2,300 years, the Platonic Aristotelian definition of knowledge has dominated Western intellectual culture. Western philosophy for sure, but as I'm going to be talking about, it became central to Western science as well. The bridge between Plato and the origins of modern science, just very briefly, just so it shouldn't be a complete dark space, is that in the ancient world, in the Greek and Greco-Roman world, the sophists and their ideas did not go away, but they got a different name. Nobody wanted to be called a sophist after Plato became so famous. So skepticism was really the philosophical school that inherited the ideas of the sophists, and the skeptics, we tend to use the word differently now, but the people who were called skeptical philosophers in ancient Greece and during the Roman period were people who didn't go around saying, we don't know anything. What they claimed was, we don't know anything. We don't have Platonic knowledge of anything in the world. What we have is probable knowledge based on our experience, and we make decisions based on probable knowledge. You can't wait until you have certainty before you act, which sounds very commonsensical, and you would think for this you have to go to college. You should have been able to figure this out on your own. In fact, if you read any Aristotle at all, Aristotle, the most popular of his rather tedious philosophical treatises, which we can not blame him for because except for one which is quite nice to read, Aristotle is not believed to have written any of them. They were all written by his students from notes that they took from his lectures, if they did in fact take accurate notes of what he said. But Aristotle himself points out that, as a matter of fact, the kind of knowledge he and Plato defended as the highest achievement of the human being, and he claims that intellectual life is the happiest form of life for a human being, meaning by intellectual life the pursuit of knowledge as he and Plato defined it. He mentions, just by the way, it is totally useless in everyday life. There's no way that you can say, I will not act until I have knowledge. So he acknowledges that in everyday life, for all practical purposes, we have to take the view of knowledge that the sophists have. But ideally, the thing to live that makes human life worth living is to pursue knowledge in the form that he and Plato defined it. So the ancient skeptics were only defenders of a view very similar to the sophist view of knowledge. The problem of knowledge between ancient Rome and the Renaissance was overwhelmed by the rise of the dominance of religious institutions, Christianity and Islam, in the West. Well, Islam overlapping the East and the West, but in both Christianity and Islam, and in a minor note in the Jewish communities of Europe as well, monotheistic religion is, as we know it, for good and for bad, is totally committed to the view that religious knowledge is knowledge in the sense of Plato. Each religious tradition claims that they have knowledge that is certain about God's existence, about God's nature, and about God's will in relation to human beings. And this certainty is a kind of a warrant for the mutual slaughter that goes on often in the name of religion, because they know what God wants and they know what God's will is. Now, in that kind of a context, prior to the Protestant Reformation, in that kind of a context, those people who wanted to do philosophy could only function if they defended a view of knowledge that was at least as strong as the religious view of religious knowledge. So the philosophers were not doing religious knowledge. They were doing philosophical knowledge and knowledge of nature. One branch of philosophy is nature philosophy. We call that science, but it was called natural philosophy until the modern period. The philosophers who wanted to do that could hardly go around saying that what we're looking for is probable knowledge when they're surrounded by institutions that defend absolute knowledge. So as a matter of fact, in the early medieval, middle medieval, and late medieval periods, from roughly speaking the time of Augustine in the late 4th century CE until the beginning of the Renaissance, I would say really until the Protestant Reformation, you have Western philosophers growing increasingly aggressive intellectually, especially after the universities were created in the 12th century, but they defended the right to pursue philosophical knowledge because it would lead to certainty in secular matters that was parallel to the kind of certainty that their respective religious communities claimed to have in religious matters. The Protestant Reformation really triggered an unusual development, totally unintended from the point of view of the Protestant reformers, each of whom thought that they had true knowledge of God's nature and God's will. And that it was not the same as what the Pope defended as God's nature and God's will. But what the unintended consequence was to say, well, who knows anything in religion? I mean, how do we know? Now that when you had one church, and the church insisted that it knew, and it had the power to punish you if you challenged it, then that was one thing. But when you have multiple churches, each of which claims absolute knowledge of God's nature and God's will, and they don't agree with each other, then what do you make of this? Then how do you evaluate the knowledge claims that are made by these different competing parties? In that context, ancient Greek skepticism was revived in the Renaissance, and in the 16th century became a very prominent and explicit force in philosophy. It could, in my opinion, it could not have happened without the Protestant Reformation. The philosophers of the 16th century were able to adopt a skeptical position and even to apply it to religious truth as if they were defending religion by claiming that religious truth had a probable character to it intellectually, but of course in our hearts we could recognize which probability outweighed the other probabilities. So while in fact they became increasingly atheistic in their philosophy, not that they denied God, but they removed God from the domain of philosophy. They removed religion completely from the scope of philosophy. They did succeed in disseminating throughout the 16th century in France and in England, in Western Europe generally, and in England, the ideas of the ancient Greek and Roman skeptical philosophers challenging the dominant Platonic notion of knowledge. Which brings us to the modern era, which inherited, by the modern era I mean the 17th century, not the 20th century. In the 17th century inherited this skeptical crisis of the 16th century, fundamentally challenging the Platonic definition of knowledge and sort of threatening to bring sophist definition of knowledge into the heart of Western philosophy. The champion that emerged for the Platonic definition of knowledge was René Descartes, who was quite an extraordinary individual in that he was the founder of modern philosophy in some meaningful sense. He was simultaneously one of the leading founders of modern science and of modern mathematics, which is a heck of a lot for one Frenchman to do, I think. He did it mostly in Holland, so that while he remained, he said, a loyal Catholic, he thought it was prudent to do his philosophizing in a Protestant country that had laws that we would call religious toleration in advance of everybody else in Europe. It was prudent to live there rather than to be within the range of the police forces of the French institutions. So Descartes defended, he's most famous, of course. I can't believe there's anybody out there who would not recognize that, well, what is Descartes famous for? I think, therefore I am. That whole I think, therefore I am line, and it's a very interesting and insightful line, which, by the way, he sort of lifted from Augustine, who had said it 1,200 years before, and Descartes very well knew that and had studied Augustine carefully since he went to a very good Jesuit college. But in those days, people were not as meticulous about plagiarism as we are, or in terms of documenting or footnoting. Descartes almost never mentions any other author, although many of his ideas do plainly come from other authors, and he didn't do this deceptively because the people who could read Descartes in the 17th century also had read Plato and Aristotle and Augustine, and so they recognized these ideas, but he did not invent the idea, I think, therefore I am. The reason why what Descartes thought the genius of that was that it answered the skeptics, because the skeptics said we cannot have any universal, necessary, and certain knowledge in the world, of the world. And yet here is a truth, which is a truth in the world, insofar as existence is in the world. I think, therefore I am, that it must be the case. I cannot be wrong about that. So you see, there is something, Descartes said, there is something that, a statement whose truth is universal, necessary, and certain, just like Plato said. And why stop there? Let's see what we can deduce from this truth. And more generally, let's see if there are any other sentences like that we can say are absolutely, certainly true, and what can we deduce from them? And if we have such a body of sentences, then everything we deduce from them using deductive reasoning will have to be true, because that's the nature of deductive logic. In a deductive logical argument, if the premises are true, the conclusion must be true. That was Descartes' position. And Descartes, not alone, revived the Platonic definition of knowledge and put skepticism in the background in the 17th century, the 18th century, and made the rationalists, the rationalism with a capital R stands for those defenders of the Platonic definition of knowledge. Rationalism returned to center stage in Western philosophy, and modern science, which emerged in the course of the 17th century through the work of people like Descartes and Francis Bacon in England, Galileo Galilei in Italy, Christian Huygens in Holland, and Isaac Newton back again in Italy. At the end of the century, Newton was joined in this pantheon by Wilhelm Leibniz in Germany, and these people were the leading figures of the movement the movement in the study of nature that created modern science. They too wanted what they were doing to be called knowledge. And the most dignified and impressive form of knowledge was the Platonic definition of knowledge. Because again, you don't want to be claiming that what you're doing is puttering around in the laboratory, coming up with opinions and beliefs that may be true, maybe they're not true, maybe they'll be true today, but they won't be true tomorrow. Galileo made the startling claim that while God obviously knows infinitely more than we do, what we know the same way God knows it. Because knowing something means deducing it from truths, and it's absolutely true. It can't be any truer than absolutely true. So if God knows the truths of geometry, that an angle inscribed in a semicircle is a right angle, and we know that, our knowledge is the same as God's knowledge. That's really quite a dramatic statement of what knowledge is. The goal is to have the kind of knowledge of nature that God, who created nature, had of nature. So that the concept of laws of nature, formulated explicitly and pursued aggressively by these architects of modern science, that's what modern science is all about, to identify the laws of nature, the timeless, universal laws of nature. That was the ideal. But there's a problem with this ideal that the founders of modern science were explicitly aware of, but chose to put under the rug, to ignore, or to push into the background, whatever term you want to use. We have to ask, as they did, what is scientific knowledge of? What are scientific theories about? The problem is as follows. The Platonic definition of knowledge means that knowledge is about reality. The sophist definition of knowledge is that knowledge is about human experience. Human experience is particular, and it changes over time. Reality, we believe, is universal and is timeless. It is what it is. So if scientific theories are about reality, we have to be able to know universal truths. How can we know those truths? Well, can we start with experience? Experience is particular. No amount of particular experience can guarantee the truth of a universal statement. No amount of particular experience, from a logical point of view, can guarantee the truth of a universal statement. It can make it more probable if you've seen 100 swans and they were all white. Well, it's good reason to believe that the next swan you see will also be white. Let's suppose you're collecting swan identifiers and you're up to 1 million. You've seen 1 million swans now in 17 countries and they're all white. I would say common sense tells you you should expect that the next swan you see is white. But then you happen to go to Australia in the 19th century and you discover black swans. So you scrub them a lot, and after a while you give up and you decide it's not a trick, they're really swans and they're really black. So you say, well, a sophist would say, you live and you learn. Plato can't say that, but the sophist certainly could. So this is the problem that the founders of science quickly came to recognize. What are our theories really about? What are they? Are they theories of reality or are they theories of experience? Are the laws of nature that we are identifying, are they patterns in experience or are they facts about the world that nature must behave in these ways? Or observations that it looks as though the next swan's going to be white, but we could be mistaken. Actually, it turns out to be quite interesting in the case of Galileo, who has, of course, a great popular and positive public image, that when he was first criticized for teaching the Copernican hypothesis, he was interrogated by a certain Cardinal Bellarmine, very educated, highly educated cardinal, and Bellarmine made an argument to Galileo, which I think is quite subtle and correct, which is that, after all, Galileo, what astronomical theory you hold is really a matter of explaining patterns of astronomical observations. There's no necessity to say that's the way the world really is. You can certainly use Copernicus's theory as a model for calculating calendars for how the planets move in the night sky. No one's going to stop you from doing that. You have no right to say, philosophically, and Bellarmine was right, what right do you have to say that that's the way the world really is? How do you know the way the world really is? All you know is that your observations match what we would call equations in your theory. Stop at that and go teach Copernicus as much as you want. But Galileo insisted that he knew that the sun was stationary and that the earth rotated around the sun, although of course he could not possibly know that. There was no evidence in his own time that that was indeed the case. It is not correct that with his telescope he was able to show that the earth moved around the sun. All that the telescope could show was that there were moons moving around Jupiter, or at least tiny little dots moving around Jupiter, which might be moons, and that Venus moved around the sun because it had phases that you could see in a telescope, but you could not see with the naked eye because Venus is so bright. That says nothing about the Earth's motion. The direct measurement of the Earth's motion around the sun only began to come 150 years, over 100 years, almost 150 years after Galileo died. So Galileo was defending what we have to recognize was a belief on his part, a belief that was motivated by his defending the Platonic conception of knowledge as something about reality, not about experience. So there's a lot of stake here. Galileo might have gone to the stake, as Giordano Bruno did on February 17, 1600 in Rome. And Galileo was definitely concerned about that as a possibility for his future. Because if he made statements about the world that were considered as obnoxious as Giordano Bruno's, then he might meet the same fate. He was, of course, an old man, politically very well connected, so his punishment was that for the rest of his life, he lived under house arrest. He was not allowed to leave his house, not even to attend his daughter's funeral, which obviously was painful, but a lot less painful than being put to the rack or being burned at the stake. So what the question that modern science had to address was, is modern science an account of the world, or is what we call the world a scientific construct? Take, for example, since I've just been talking about Copernicus, take, for example, the solar system, what we call the solar system, is a theory of the relationship of the Earth and the Sun and the planets, a picture of the way the things are out there, or is what we call the solar system sort of, I hate to use this expression, but I can't avoid it, an invention of the scientific community that works really well in making calculations about the relationships between the motions of the planets. Because that was what the church originally wanted anyway, why they sort of made Copernicus a part of the commission to try to fix the Christian religious calendar, because the length of the year was way off, and it had caused Easter to be coming out much too early. Easter was beginning to come out in the winter. And it can't come out in the winter. It has to come out in the springtime. So the calendar needed to be reformed, and Pope Gregory in 1583 did indeed reform the calendar, and at that point they had to stick 11 days into the calendar in order to add 11 days to the calendar to get Easter back where it belonged. And with these new astronomical observations that gave a much more accurate figure for the length of the year, the calendar has been pretty good. Until then, at least as far as religious rituals are concerned. So you have a choice. Is science an account of the world, or is the world a scientific construct? It may seem obvious that science is an account of the world. After all, we all know that it took about 100 years, but between Copernicus and Isaac Newton, Copernicus in 1543 and Isaac Newton in 1687, when he published his mathematical principles of natural philosophy, it was obvious that we had a theory here that the sun was in the center of the solar system at one point of an ellipse, and all the planets rotated around the sun in elliptical orbits. and we could calculate these orbits very carefully, and we could show that there was a law of nature that related the speed of the planet, how long it took to go around the sun, and the distance of the planet from the sun. So the distance and the speed were correlated. Everything was explained. It's a beautiful picture. But it's not true. In a very common sense way, that is to say, if you could take a snapshot of the solar system from way out in the galaxy somewhere, above the plane of the Milky Way, and you took a high-resolution photograph of the solar system, you would not see planets moving in ellipses. An ellipse is a closed curve. It means that you go around it, you come back to the same point eventually. And that would be true if the sun were really standing still. But the sun isn't standing still. The sun is rotating around the center of the Milky Way. And the Milky Way itself is rotating around the center of mass of a cluster of galaxies that we call the local cluster of galaxies, made up of somewhere between 6 and 30 galaxies, depending on how you count big and small galaxies. And that whole cluster is moving towards a constellation called Virgo. So no planet ever comes back to the same point in space. It is a pretty picture when you see, the solar system. You have this magnificent body called the sun in, not the center, but at an important point on a curve called an ellipse, off-center. It's called one of the two focal points that an ellipse has. And the planets move around in elliptical orbits. They behave for observational reasons as if they did, but it's not true. Right? So just even in a simple case like that, there's a real question about whether scientific theories give us a picture of the world or whether what we mean by the world, the solar system, is a scientific construct. We could say the same thing about DNA. Beautiful double helix. Try to take a microscopic photograph of the double helix. You know that the DNA in each nucleus is all scrunched up into a tight little ball. It's not a beautiful double helix inside the nucleus. You have to stretch it out and cut off a piece that you can make an X-ray crystallograph out of. And then it looks very pretty and like a double helix. The double helix is true in an ideal sense and in terms of the chemical bonds that are involved, but you would not see a double helix if you could actually see the DNA coiled in the nucleus, in the nuclei of your cells. So the problem, how can you defend the Platonic definition of knowledge? Given what I've just said, you would think that, well, if Descartes and Bacon and Galileo and Huygens and Newton and Leibniz, they knew all of this. Of course they knew all of this stuff. I didn't make this up. If they knew all of this, why didn't they all take the view that I have been calling loosely sophistic or skeptical? Because they believed that the experimental method could bridge the sophist definition of knowledge and lead to the Platonic definition of knowledge. That the experimental method could lead us from particular observations to universal laws safely. That the experimental method could give us the certainty about universal generalizations that adding up white swans cannot give us. That was the belief. And so what we have to ask is, can the experimental method really do that? So keep that question in mind, because I'm going to come back to it in a couple of slides. But for the moment, let's just ask, what difference does it make? Well, I've actually suggested some of the ways it makes a difference. If reality is the object of science, if what scientific knowledge is about the real world that exists independently of the human mind, then in order to know whether a scientific statement is true, we need what philosophers call a correspondence theory of truth, a correspondence criterion of truth. How can we tell that a theory corresponds to reality? The problem is we can't get out of our minds in order to see reality, to see whether our theories are correct or not. Our theories are products of the mind. All of our thinking is a reflection of our experience, unless you believe in, and some people have, unless you believe in ecstatic visions in which you can escape the mind and body and look with naked eyes, as it were, on reality. How can you compare the two? Right? So if you take the view that science corresponds to reality, if reality is the object of science, then we need a correspondence criterion of truth. And you also must accept, and this Plato had no problem with, and in fact, in my opinion, almost almost no scientists have a problem with, that the object of scientific knowledge exists independently of scientific inquiry and antecedent to scientific inquiry, before the inquiry. Whatever the world is, it is. The world's not waiting for us to study it before it becomes what it is. It is what it is, and our job is to try to explain it as it is. Then scientific knowledge, like Plato's definition of knowledge, must be universal, timeless. It must be abstract. Why must scientific knowledge be abstract? Because it can't be particular. If it's particular, it can't be universal, necessary, and certain. So in order for it to be universal, necessary, and certain, religion cannot have knowledge of reality. Religious people can believe whatever they want to believe, but they cannot have knowledge unless they can meet the criteria of scientific knowledge. So that's all packed into buying into that particular definition of knowledge. If, on the other hand, experience is the object of knowledge, then we don't need a correspondence theory of truth. What we need is a theory of truth in which our ideas are coherent, they are consistent with our experience. Well, we can check that at any time. If somebody tells me that they have a model of the atmosphere that predicts the weather accurately 5 days in a row, I can check that by looking at their predictions, and after a while I say, you know, you've been right for 100 5-day periods. I'm willing to believe that your model is consistent with experience. Will it someday be proven wrong? Will it rain on a day when you predicted sunshine? Could happen. We're not in absolute truth here. Because experience may change. New things may happen. A volcano may erupt, or China may suddenly become a massively industrialized nation that changes the atmosphere. The model that I had 30 years ago, which worked terrifically until this new eruption of material into the atmosphere, pollutants, let's call them, then I now have to come up with a new theory. That's perfectly okay if you take the view that the theory of truth is merely coherent with experience. The next point is more scandalous sounding. If experience is the object of scientific knowledge, then scientific objects, what we mean ultimately by the world, is actually created by the process of scientific inquiry. That sounds really strange. Did scientists create atoms? In a certain sense, they did. Because if you talk about the world in atomic terms, and you say that, well, I believe, as scientists did at the time, and mostly still do, that all natural phenomena are the result of matter in motion. And matter is made out of atoms. That's a theory. That's a scientific theory. And there are some experimental reasons for adopting that theory. Let's say there are very good reasons. What is an atom? Well, you can't look at it. You can't look at matter and say, oh, I see, yeah, there's one. Oh, look, it's chubby and it's got two little legs that it's waving around. The scientist tells you what an atom is. And the scientist said, from 1806 to 1896, the scientist said that atoms were tiny little billiard balls that could not be broken down by anything except God. At least that's the way Newton said it before 1806. 1806, they dropped the God part out. Atoms are tiny little billiard balls, and they are fundamental units of matter. They have no internal structure, and nothing can break up an atom. 1896, J.J. Thomson discovers that atoms do have an internal structure, that they have electrons in them, tiny little dots of negative electricity that are somehow arranged inside the solid stuff of the atom. So we have to redefine what an atom is. So now, in a certain sense, scientists have created a new object in the world. Did those other atoms exist before J.J. Thomson? Well, of course. He didn't make nature what it is. But on the other hand, before he said that, nobody ever meant by the word atom what he said the word atom now had to mean. A mere 14 years later, in 1910, Ernest Rutherford discovered that the atom is not solid at all. It's mostly empty space. Over 98% of the atom is empty. It's a tiny little nucleus, between 1% and 2% of the volume of the atom, and then there's these tinier little electrons that orbit it in various ways. He didn't understand the orbits yet. That came a little later. So the atom turns out we have to redefine it again. You have to change all the definitions in all the textbooks. Now the atom is not solid without an internal structure. It's mostly empty, but the nucleus is solid. So we keep solidity. Then in 1935, we discovered that the nucleus is mostly empty space, made up of these tiny little protons and neutrons arranged in shells. That's funny. So we now have to redefine the atom because we didn't know about the neutrons until 1932, and we didn't know about the emptiness of the nucleus, but now protons and neutrons are solid. So matter is still made out of solid stuff. It's just that they're very small little bits called protons and neutrons. Then in the 1960s, the quark theory of matter came along and said, protons and neutrons are mostly empty space. They are made up of things called quarks. Quarks are much, much smaller than protons and neutrons, but they're really solid. I mean, quarks really are solid. And that's where we are at the moment. But, especially given the difficulty of getting a new mortgage, I wouldn't bet the mortgage on the solidity of quarks. It could be that in 10 to 20 years, the mortgage crisis will have been resolved, but scientists may decide that quarks are mostly empty space. And in fact, that is not intended as a joke, because it could be within a year. When the Large Hadron Collider at CERN in Europe is turned on this summer and debugged, assuming that no lawsuits interfere with it going on, that the Large Hadron Collider will reveal the presence in nature at some point in the very distant past of the universe of a peculiar particle called the Higgs boson, which I will not say anything more about, except that if they find that particle, that will strongly reinforce a theory within quantum mechanics that all mass is an illusion, and that there really is no such thing as solidity anywhere in nature, that what we call mass is the interaction of massless particles with one another in a peculiar way, like trying to move through molasses, and that the drag of photons, of electrons and protons and quarks through this Higgs energy field, which is itself immaterial, causes the illusion of mass. So it may well be the case that within a year or a year and a half, the Europeans have bet about $8 billion on this machine, and everybody will be very chagrined if they do not succeed in finding the Higgs boson. So one can only hope that nature cooperates and lets them find it. So in a certain sense, the object of knowledge is created by the process of scientific inquiry. The instruments that we use, the kind of experiments we do, lead us to say, this is what nature is made of. And then we change those definitions, and we change those definitions. There is nothing in our experience that corresponds to what the scientists mean by the sun, or for that matter, of the earth. We talk about the earth, they talk about the earth, but the earth as a scientific object is not the earth as we experience it. I don't think any of us have such sensitive inner ears that you can feel the continents moving. It seems at least implausible. So if experience is the object of scientific knowledge, then knowledge is contextual, contingent, probable. It sounds very much like the sophists. It is evolutionary. Scientific knowledge evolves as our experience changes. Scientific knowledge is concrete, not theoretical, not abstract, on the view that science is about experience, then because experience is concrete, so scientific knowledge is concrete. And science is praxical. Now, I deliberately used a Greek word, maybe slightly abused a Greek word, which in ancient Greece was in fact the opposite of theoretical. Science is praxical in that it has to do with the way we interact with the world in experience. And it is validated by whether it works or not, just like know-how. So on the view that science is about experience, knowledge and know-how tend to converge. The meanings of those terms tend to converge, even though the Platonic view keeps them very, very far apart. And from this perspective, induction, not deduction, is the fundamental logic of science. And although scientists would all say, of course we use induction, as a matter of fact, all scientific results are presented deductively. All scientific theories are presented deductively because it's only if you present them deductively that you can make logical inferences that are considered guaranteed predictions. And then when you do the experiment and the prediction comes true, then you get credit for the truth of the theory. I'll talk a little bit more about that on the next slide. What criteria of truth are there for scientific theories? There are three. Scientific theories are considered true by scientists if they have explanatory power, if they make correct predictions, and if they give us control over experience. Typically, this takes the form of technologies that are based on a scientific theory and that work, like the electric telegraph, for example, to take a homely example, or the internet for a less homely example. So explanation, prediction, and control are certainly criteria that scientists apply to theories before they make a judgment that that theory is true or not. Now, they don't use all of them with equal weight. Very often, scientists will accept a theory that they believe has great explanatory power, even if it has not yet made a prediction that has been confirmed experimentally. Sometimes they adopt a theory because it has been confirmed experimentally before they understand exactly what the implications of the theory are, what it is that it explains, because they're so convinced by the experiment. Rarely, I can't think of an example of a theory that scientists consider true merely because it worked, because it gave us control over experience, because somebody built a machine based on it and the machine worked. But the broader question is, do these three criteria of truth guarantee that reality, not experience, is the object of scientific knowledge? That scientific knowledge is about the world independently of our reasoning about it or not? And the answer, of course, is no, because the history of science reveals that over and over again, scientists embraced as true theories that had explanatory power, that made correct predictions, that gave us control over experience, and then we eventually decided were wrong. Right? So lots of theories. The history of science reveals that these three criteria are not decisive. They can all be present, and a theory could eventually, we can think of the electrical theories that were used to make the first electric telegraphs. The electric telegraph in the 19th century, which was the internet of the 19th century. The telegraph worked. International, the undersea telegraph linked, the cables linked all of the continents by somewhere around 1875, 1880. But we don't think those electrical theories are correct. They happen to work, but that's almost not an accident, but it's only incidental to what we believe the true theory is. Even the theory that replaced those early electrical theories, Maxwell's electromagnetic theory of the 1860s and 70s, which works beautifully and is behind the telegraph and the television and lots of other technologies, we don't consider that to be the decisive, correct explanation of electromagnetism today, because it's been replaced by a quantum theory of electromagnetism. So explanation, prediction, and control do not guarantee, and the reason is, and now I'm coming back to a question that I asked you to keep in the forefront of your thinking, and you probably did not do this while I've been carrying on, and that was, can the experimental method indeed bridge induction and deduction? And the answer is that it cannot, and they all knew that it cannot, because it is an example of what every school child who got to, well, not a school child, but every high school student from the time of ancient Greece until the 19th century had to study Aristotle's logic. And in Aristotle's logic, you will find, and as an example of fallacious deductive reasoning, a fallacy that is called the fallacy of affirming the antecedent. Unfortunately, some people call it the fallacy of affirming the consequent, but I like this version of it, the fallacy of affirming the antecedent. Now hold on here, there are some symbols, but don't panic. This is really neat. It's very simple. Let's suppose you know the truth of a conditional statement, which is symbolized here as if P then Q. It means if P is true, then Q is true. And you know the truth of that statement. Doesn't matter how you know it. You can certainly know the truth of some conditional statement. For example, if the general theory of relativity is true, then before we do any experiments whatsoever, we can deduce from the theory that light rays will bend if they pass close to a dense body like the sun. That is a deductive consequence of the general theory of relativity. It's just like saying moving my bishop this way on the chessboard is a legal move. It follows deductively from the rules of chess. Now what matters, the difference between the general theory of relativity and a move on a chessboard is we do an experiment, and what happens? We discover that, son of a gun, light rays are bent when they pass close to the sun. And so we say, wow, Einstein is a genius. theory is true. Now, Einstein was a genius. The question is, did the experiment prove that the theory is true? So now, go back to, if we have the truth, we know that it is true, that if P is true, then Q is true. If somebody comes along and somehow shows me that P is true, then of course I'm guaranteed that Q is true. But what if someone comes along and shows me that Q is true? I do the experiment, and I measure it. And now I want to say, well, you told me, if the general theory of relativity is true, then light is bent next to a star. I went and made the measurement, and it is bent. So that proves that the theory is true, right? Because it made a correct prediction. Wrong, says Aristotle. There could be other reasons why the Q part of a statement, if P then Q is true, is true. There could be other reasons why Q is true. You cannot go backwards. If you know that if P is true, then Q is true, then truth flows, so to speak, from P to Q. You can't flow backwards from Q to P. That's why I like calling it the fallacy of affirming the antecedent of a conditional sentence. This is a well-known logical fallacy, but it is the experimental method. It is only a fallacy in deductive reasoning. In inductive reasoning, it's a different story. You say, well, the experiment gives me some probability for believing that the theory is true, but it doesn't guarantee the theory is true. So inductively, it's not a fallacy. Deductively, it's a fallacy. If you're trying to defend the Platonic view that science is about a reality independent of our thinking about it, and you're using deductive reasoning, then that is a fallacy. That means the experimental method is a fallacy. And everybody in the 17th century who could get to be a scientist, the term didn't exist in the 17th century, a natural philosopher, knew this. And most of them wrote about it. But they said it's so powerful when you do an experiment and it makes and it confirms an unexpected prediction of your theory. How could you not think that your theory is true? It's got to be the case. Okay, so it's a technical fallacy in inductive reasoning, but how could you not believe it? So the answer to the question, can the experimental method bridge induction and deduction? The answer is no. Now we go back to the question that came up. What are scientific theories theories of? Are they theories of reality, or are they theories of experience? In the 19th century, this became a major issue inside science. Forget philosophers. We know that they don't have anything to do with reality. What is the scientist every major working scientist of the 19th century was involved at some point in their career with this controversy. What are scientific theories of? One of the most famous of these controversies had to do with what is heat. A controversy that had been brewing for over 100 years by then. There were two camps. One camp held that heat was the result of a weightless fluid called caloric, which we all are concerned about in terms of diet, same calories. That there was, what made something hot was when caloric escaped from it. When you rubbed it and caloric escaped from it, that made it hot. The other view held that, no, there is no such weightless fluid, you fool. Heat is just the motion of the particles of which matter is made up. Heat is not a thing at all. It's a state of motion. And this became quite a nasty controversy. Some very clever experiments were done, which the textbooks say proved that heat was motion, but in fact they did not prove it. Those experiments were done in the 1790s by a bizarre character who called himself Count Rumford. Because in the early 19th century, major physicists, including one of the greatest physicists of his time, Pierre-Simon Laplace, believed in the caloric theory. Right into the 1840s and 50s, eminent physicists believed in the caloric theory, and others were strongly defending the theory that heat is motion. He was, at the time, a young French mathematical physicist named Joseph Fourier, in 1807, wrote a paper on a mathematical theory of heat, in which he starts off by saying, listen, I don't want to get involved in this controversy. I don't care what heat is. I'm just going to describe how heat behaves. And he submitted this to the French Academy of Sciences for a prize competition. The judges included Laplace. Laplace was totally committed to the view that the job of a physicist is to describe reality. And he was also totally committed to the caloric theory as being a true account of what heat really is. He hated this idea of a theory in physics that didn't make any commitment about reality, it just described experience. And for 15 years, he blocked the publication of this essay. It was finally published in 1822, 1823, and was extremely important. The equations that Fourier used to describe how heat flows through a conducting material as a function of time became fundamental to 19th century physics in many other applications besides heat. And the mathematics that he used in his work became even more fundamental in engineering, and especially in 20th century engineering, something for those of you in the audience who know about Fourier transforms, that comes out of this work. Fourier triggered a consciousness among scientists that there was an issue in their theories. Are their theories about reality, or are their theories descriptions of patterns in experience? There was a desire for the theories to be about reality, but the scientists recognized that, logically speaking, they didn't really have a right to claim that. That was a claim that they could not justify. And so, throughout the century, you had even more complicated theories that started being formed, mathematically more complicated theories. In particular, James Clerk Maxwell's mathematical theory of the electromagnetic field, a major development in science. Maxwell himself was part of a tradition including Michael Faraday and a character called Lord Kelvin. He really was a lord. He was made a lord after overseeing the successful version of the transatlantic telegraph cable by applying physics to the design of the cable, whereas the first version made by an American entrepreneur failed about a month after it went into use. Kelvin and Faraday and early Maxwell believed that their job was to come up with a mechanical model of electromagnetic phenomena, because if you don't have a mechanical model, if you can't explain something in terms of matter and motion, it's not real. Eventually, in the 1860s, Maxwell acknowledged that, well, of course, there is some reality out there, but I give up. There are an infinite number of ways that God could have arranged for there to be all of these electromagnetic phenomena. My equations work. That's all that matters. The electromagnetic field is as real as the equations that describe it. What the field is, what it's made of, what's really happening out there in the world, that's not part of my job as a physicist. And this was a very typical response throughout the century. And it highlighted two approaches to what scientific knowledge is knowledge of. The one that I have been calling knowledge of reality, I will now call a kind of an archaeological approach to scientific knowledge. That scientists are like archaeologists. No, an archaeologist digs stuff up. They clean off all the mud, and in the end, it is, let's say, a two-handled urn with a picture on it of Greek maidens and a cow being led to the slaughter, sacrificial slaughter. And who the archaeologist is irrelevant. I mean, it's not because, well, you know, a Russian archaeologist, it would be a one-handled vase. If it's an American archaeologist, it's got a two-handled vase. If it were French, the women would look like this. If they were Mexican, the women would, no. Whoever the archaeologist is, you brush off the mud, it is what it is. The archaeological model of science is that scientists are just describing the way nature really is. The alternative is that scientists are constructing nature. They are construing experience. Construal means to interpret. Here are the facts. How can we make sense of them? Well, there are lots of ways of making sense of them. A scientific theory is one particular way of making sense of any given set of experiential observations. But there are multiple possible interpretations of experience, and furthermore, when experience changes, as experience inevitably does, then you have to expect that the interpretations are going to change. Thomson finds electrons inside the atom, and then all of a sudden you need a new theory of matter. Rutherford finds nothing inside the atom, and he's got to find, and we need a new theory of the atom to explain that nothingness. And it goes on like that. So it sounds as though, I hope you're keeping score, that the sophists are making a big comeback. But the definition problem that I talked about in terms of knowledge and truth and reality, what those terms mean, comes back when we talk about, wait a minute, what do you mean by experience? I've been using this word from the beginning of my talk, and hopefully some of you at least have made a note of, well, how can I get away with not defining experience? Well, of course, there's no correct definition of experience either. There's no absolute definition of experience. But it seems to me that this conflict between the two definitions of knowledge, this kind of schizophrenia within the scientific community about, are our theories about the reality, or are they about the experience? Is the world a name for reality, or is the world a name for the scientific interpretation of experience at any given time? That it's critically dependent on what you mean by experience. In Western philosophy, experience has typically been meant to apply to what goes on in here. That experience is a name for our consciousness and for our ideas and sensory perceptions. If that's the case, if that's what you mean by experience, this knowledge problem that I have been describing is unavoidable and it's insoluble. Once you start that the object of your thinking is inside your head, you can't get outside your head, because you can't get outside your head. So you're trapped. This was a move that Descartes made. This was a move that was even reinforced by the empiricists like John Locke, who also starts off by talking that knowledge is about the agreement or disagreement of our ideas. But we cannot ever we can never know, John Locke admitted, that our ideas corresponds to what's outside our mind that causes our ideas. We can't know that because we can't see what's outside our mind except by using our mind and our nervous system, our eyes and ears, etc. But if you mean by experience what John Dewey and others have meant by experience, that experience is a name for the way we interact with the world, that it is a name for our evolving, ongoing, dynamic interaction with reality, which is a name for one aspect of experience, and that the world is already inside us when we think about it, that our thinking goes on in the world. Dewey had a cute way of putting this. Think of a mountain like Mount Everest. He says Mount Everest is not on the earth, it is of the earth. Mount Everest is the earth. It's an extrusion of the earth. It doesn't just sit there like it was plopped down from outer space. Experience is an extrusion it is an expression of our interaction with the world. It's not that the mind is here and the world is there and then we have some experience of that inside the mind. There is no mind as a thing separate from the world as a thing. Our mind, our thinking, our feelings, our sensings go on in the world, and we try to make sense of that interaction so that there is no tension between mind and world, but it also means that there is no such thing as absolute knowledge of the world, because all of the things we claim to be knowledge are part of our interaction, and the interaction changes over time. So our knowledge evolves over time, and we should never be arrogant about the knowledge claims that we make. Now, of course, Dewey's definition is not correct in any absolute sense. It just seems to me that that kind of a definition, others have held it besides Dewey, but I like Dewey's way of putting it. I think he was the first to put it as coherently as he did with respect to science. That the definition of experience turns out to be, I think, a very useful way of seeing how we can respect scientific knowledge as the most powerful kind of knowledge that we are going to get about experience of its sort, without having to say that because it doesn't live up to the absolute criteria, it doesn't deserve the term knowledge. So now, the world according to science is neither reality nor experience. The world is historical. What we mean by the world is historical. Theories, experiments, objects, data, they all evolve over time, they change over time in the way that I've discussed with respect to the atom. You give lots of examples of that. Contrast theories in science in 2000 with the theories in 1900, and you see, we think, oh, they were wrong about everything. But in 1900, they looked back to 1800 and said they were wrong about everything. What's the probability that in 2100, scientists will look back to 2000 and say we were wrong about just about everything? It's very, very high, right? So that's what I mean when I say that the world, as scientists conceptualize it, evolves according to time. That means what we mean by the phrase, the world evolves. We don't know that the world independently of us, but we can't give any meaning to that. Insofar as we can talk about the world, it changes over time because the way we talk about it changes over time. Does the world converge on reality? I can't answer that question. There's no way of telling because we can't get outside our minds. We can say that scientific theories become better and better and better as explanations of more and more complex phenomena. They make more and more sophisticated predictions, and they give us more and more sophisticated control over experience. And in that sense, science is objective and progressive, always relative to assumptions that cannot be proven to be true based on experience, no matter how many experiments that you do. So all scientific knowledge claims are relative to some set of assumptions that are justified because they give us good explanations, they give us they make predictions that are successful, and they give us control. So science, in fact, as it changes historically, there are no revolutions in science, in my opinion. There is evolution. Scientific theories evolve in response to changing experience. So science is a measure of experience, and the greatest sophist of the ancient Greek world was Protagoras, and he was the one who said that man is the measure of all things. Science is the measure of experience. Applying scientific knowledge to experience, and in particular to public policy issues like global warming, is an open challenge. By an open challenge, I mean something like this. Science cannot give us the answer to any policy question, for the same reason that Aristotle said that theoretical knowledge is useless in everyday life. Science cannot do that. The challenge of science is to take science as our best contemporary understanding of experience, and then to make decisions based on the knowledge that scientists give us. That's a challenge, but it's only a challenge on the sophist view of science as our best understanding of experience as we have it today. Don't expect absolute knowledge and then wait for absolute knowledge before you make your decision, because science cannot give us absolute knowledge. It would be nice if I could wrap up by saying, now, global warming is a fact, and we should all sell our SUVs and buy the American analog of a Toyota Prius, but I can't do that, because even if I were an atmospheric scientist, I would have to say, well, this is the model I'm using, these are the assumptions I make, this is what seems to be the case, this is what follows from my model, from my assumptions. Do I know that my assumptions are correct? No, but they do seem to work. Might they be wrong? Yes. So if you're going to say, well, I am never going to act on the basis of such probabilistic knowledge, well, of course, you would not say that to your doctor as a rule, right? And they know a hell of a lot less about your health than atmospheric scientists know about the atmosphere. Thank you very much.
You just stay out there now. Just stay out there.
You can tell them if you want to do questions. No?
So we do questions now. We go to the mics, and if anybody has to leave, do it quietly, please. You probably answered everything you ever wanted to know.
Does anybody have a question?
There he is. There we go.
Oh, yes, we do have a question.
Go ahead.
Dr. Goldman, it seems to me you might help me figure out Descartes a little better. I understand that he came to the conclusion that I think, therefore I am, but he also said that's the only thing I can know. He introduced the whole idea of radical doubt.
Yeah.
So, yes, he came to yes, this is certain, but he also said everything else is uncertain in a way. Okay, thank you.
That's very good. That's really very, very good. Descartes, what Descartes wanted to do, because not only was he an extremely clever man, but he thought he was an extremely clever man. What Descartes wanted to do was, he was so impressed by what he thought he could do with I think, therefore I am, that he raised the stakes. You know, like you're playing a poker hand and a poker game, and you're absolutely confident that you have a winning hand, and you bet every penny that you've got. So Descartes, in the Meditations, invented this idea that I am going to doubt everything that I could be wrong about, right? And this is exactly Plato's definition, right? That knowledge is that about which we cannot be wrong. I am going to examine everything I think I know, and I'm going to put it to the test. Could I be wrong about that? And I'm going to throw it all out. And then he shows that he could be wrong about everything, except I think, therefore I am. That is absolutely certain. That cannot be false, because a non-existent thing cannot think. So if he thinks, he must be. So now I can start working my way out of the absolute doubt. He thought. Unfortunately, his next conclusion, his next inference, which he thought was deduced, was, therefore I am a thinking being. And that's when he made this fatal mistake of locking himself inside his mind and concluding that the mind was separate from the world and there was nothing in common between mind and world. And then he trapped Western philosophers for the next 300 years inside this notion that the mind and the body are two totally different, non-interacting things. But so you're quite right that he started with radical doubt in order to show how powerful I think, therefore I am is as a truth. But then it turned out that by the end of the meditations, he wasn't left with anything that he knew except not mathematics, and then he had to rely on innate ideas, which by and large we don't accept. So I would say he failed.
So is there anything he contributed to scientific method then?
Descartes?
Yeah.
Oh yeah, sure, because see there's a big difference between doing science and talking about science. Scientists do science and they do it very well. They often don't talk about it very well. There's a cute story. The British psychologist R.D. Laing in the late 1960s wrote a book in which he mentioned, by the way, a scientist could come up with a thermodynamic theory of human metabolism and argue that human beings are just like refrigerators. And you could get a Nobel Prize for that. But if the scientist went around saying, I am a refrigerator, then he would be institutionalized. So Descartes said things about science that turn out we consider to be wrong. But he did great science. I mean, he was the author of the modern mechanical theory of nature, philosophy of nature, that all natural phenomena must be explained in terms of matter and motion, which was enormously influential for centuries until energy was sort of formulated in the 19th century. It was Descartes who was responsible for shifting European mathematics from geometry to algebra. Well, that's a little strong, but he played a major role in arguing in 1629, I think it was, that all geometric problems can be solved better in algebra. And within the 17th century, algebra replaced geometry as the mode of doing mathematics, especially in science. So yeah, he discovered the reflex arc, he discovered the pineal gland. So he did a lot of good science, but his theory of science was not successful. Yes?
Thank you.
Thank you, Dr. Goldman. You talked about the way in which current science becomes more and more detailed and is able to deal more and more accurately with more complex matters, and is thus becoming better. But in the time of Ptolemaic understanding of celestial mechanics, the Ptolemaic picture was not working very well, so they kept adjusting it and getting it to the point where it could successfully deal with more and more complex matters and apparently be more and more correct. Question: how do we know that current science is not digging us deeper into another Ptolemaic pit?
We do not. That's the short answer. Now, let me just give you an example of this. I'm not trying to be flippant. The two greatest intellectual achievements in science in the 20th century are the general theory of relativity and quantum mechanics. Both of those theories have been experimentally confirmed over and over and over again with remarkable precision. They cannot both be true because they contradict one another. Scientists have known this since the 1930s, and every effort to reconcile them has failed. So we can be confident that at least one, and more probably both of these theories, will be replaced within the next 30 to 50 years. So you're quite right. We cannot know that. A British philosopher of science, Mary Hesse, very, I think, underestimated and not as well known as she deserves to be, argued in one of our books exactly this point. Looking at the history of science, we should not suppose that our theories are the ones that will not be overturned. They probably will.
Thank you.
Yes?
Upstairs.
Oh, I'm sorry, upstairs, yeah.
Thank you very much for coming. I really appreciate all the information and thinking that you're putting out. And what's very important is the questions that you're bringing to our minds. What is truth? What is knowledge? What is reality? Those are where the rubber hits
That's
the road.
what keeps me employed.
Right. But I think there's one that's much more important that hasn't been put on the table, and that's very important in terms of motivating how we behave in the world, and that's what is love?
Well, I certainly agree with that, but I think that I can legitimately say that it was outside the purview of this particular lecture, since I tried to focus on science. If you were to ask me as a person, what's the most important thing in the world, I would say love.
Don't give me a cheap answer. I want just.
That's it. I mean, I wanted to say I can't work love into science. There was a time when love was part of science. I actually wrote an article years ago, published an article, it was a chapter in a book called From Love to Gravity. And I talked about the rise of modern science was coincident with replacing the Renaissance view that the universe was held together by love that was a consequence of it being the product of a creator, so that everything in the universe had a natural relationship of attraction and sympathy with everything else in the universe. That picture was replaced in the 17th century by a universe held together by gravity, an impersonal, inhuman force. So I'm not trying to be flippant. There was a time when love was part of natural philosophy, Renaissance magical nature philosophy. Modern science rejected that picture and replaced all such notions with impersonal, objective forces. And so, in a certain sense, there really is, within the framework of modern science, there really is no room for love. Although in another lecture I could talk about love. Yes?
Yes, sir, I just want to go back to two of your slides and ask a question. You said in one of your slides that experimentation cannot bridge the gap between induction and
right.
deduction. But you also said that Plato defended his view by pointing to mathematics.
Right.
So how did we, if that's true, how did we get knowledge of mathematics?
That's a great question. It is a question that is, I wouldn't call it a burning question for mathematicians, but it is a question that mathematicians suffer from the same problem. The great philosopher, mathematics, and mathematical logician, so he did good work in mathematical logic, Paul Benacerraf at Princeton, put this very poignantly in a particular essay, an essay he published a couple of decades ago. Do mathematical objects exist independently of the human mind? Plato said they did. That poses a problem. How do we know them if they exist independently of the human mind and they don't exist in nature, which everybody agrees, all mathematicians agree on that. There are no circles, there are no mathematical circles or triangles and squares in nature. So how could we know about objects that exist independently of, well, you have to believe in revelation or innate ideas or in something like God, communing with God, and various theories like that. Plato had a theory which he may or may not have believed, that all knowledge was remembering. That when we lived in heaven, before we became embodied, that we knew all these truths. And then when we're born, we forget them. The trauma of birth, the trauma of being a soul trapped in a body causes the soul to lose its knowledge, and some people are fortunate enough to get some of it back. And mathematics is an example. Well, these are somewhat far-fetched. On the other hand, Benacerraf said, if you deny that mathematical objects exist independently of the human mind, and you say that mathematical objects, like the sophist said, are created by the human mind, then how do you explain why mathematics works? How can mathematics work in the world? Mathematicians invent these really crazy ideas. I mean, 19th century knot theory. And then it turns out that these are wonderfully applicable in physics and in engineering. How can it be? And we have no answer to this question. In fact, both of those, Eugene Wigner, a Nobel Prize-winning physicist, also at Princeton, one of the major contributors to modern quantum mechanics, he wrote an essay about 1960 called On the Unreasonable Effectiveness of Mathematics. It really is a mystery. How can we know so much math if it doesn't come from the mind? And if it comes from the mind, why does it work? So that's another very good question. One more.
Hi, with regard to this bridging of induction and deduction,
Right.
it seems that Robert Pirsig kind of touches on this in Zen and the Art of Motorcycle Maintenance with the bridging of the subjective and objective.
Right,
with the
romanticism
topic
and
of-
rationality.
with quality being the unifying force.
Yeah, yes, but that I think is I think that would not be recognized as a scientific hypothesis. That would not be, I think it's an interesting idea. What Pirsig was trying to do actually is an example of what I've been talking about. There is a broad recognition by scientists and by people who study science that there's a real problem bridging induction and deduction, and the question is, how do you do it? So just as with mathematics, trying to find some way that we can recognize the power of mathematics without having to admit that mathematical objects are independent of the human mind, or somehow that we know them but we can't explain why, there is clearly a close relationship between induction and deduction. I don't think Pirsig's sort of romantic way of doing it succeeds. I think that Dewey is much closer here, that you have to redefine what you mean by experience and recognize that experience is not passive. We do not passively receive the world inside our heads, but that we interact with the world and that our thinking is an expression of that interaction. That seems a potentially more fertile way of bridging the two than Pirsig's way, but I agree with you. Pirsig was trying to do that. Oh, yeah, one more? I thought I would.
You haven't mentioned the theory of the unknown. Wasn't that a big turning point toward the middle of the 20th century in science?
The theory of the unknown?
Yes.
Uncertainty.
Uncertainty.
Yeah.
Yes, uncertainty.
Oh, good, because I could legitimately claim that I don't know anything about a theory of the unknown. But the theory of uncertainty, yeah. Well, I assume that you're mentioning that because in quantum mechanics, one of the most fundamental features of quantum mechanics is Werner Heisenberg's principle of uncertainty, formulated in 1926, initially understood by Heisenberg and by Niels Bohr, his sometimes mentor, that when we did experiments at the very microphysical level, the experiments interfered with what we were, like if you want to measure the behavior of a single atom. So in order to do that, you have to bounce a photon off it. And the photon is, in order to be able to register the atom, you have to use a photon that's energetic enough that it actually bumps the atom out of the way. I'm being a little simplistic, but roughly speaking. So Heisenberg argued initially that we must recognize that certain quantities cannot be measured at the same time with unlimited accuracy because the experiment interferes with the quantity. Take a simple case. Let's suppose you want to know how fast something is going. At an instant of time, at noon, tomorrow afternoon, we want to know exactly how fast some object is moving. Well, and we also want to know how much momentum it has. So how fast it's moving and how much it weighs will tell us how much momentum it has. In order to measure the speed, we have to let the thing move, because motion is change of position over change of time. If you stop the thing, you can measure its momentum perfectly. But if you stop it, it has no velocity. You can't, if you let it move, then you can measure its speed, but then you can't know its momentum exactly. So those are a pair of quantities that you cannot know at the same time with unlimited precision. Subsequently, and I think this is what you were getting at, the uncertainty has become a much more fundamental feature of quantum mechanical picture of the world. According to quantum mechanics, nothing can be certain. No statement about the world can have an absolute value. So, for example, in quantum mechanics, there cannot be such a thing as a vacuum. There cannot be a region of space-time that is empty of matter and energy, because if it did, you would be able to say about it, it has zero matter and energy. Zero is an absolute number. It means with absolute precision, there is nothing here. So quantum mechanics doesn't allow that. That means in regions of space where there doesn't seem to be any matter and energy, really, on a very, very short time frame, particles are popping into and out of existence very, very, very rapidly. They're popping into and out of existence from nothing. Now, this sounds really Alice in Wonderland, But in 1947, a physicist named Casimir came up with an idea for experiment which has subsequently been done over and over again. I think probably you couldn't even win a high school science fair with this anymore, which actually showed that this is true, experimentally, that in fact it is the case. That quantum mechanics, the principle of uncertainty, is a very deep statement. It is now taken to be, in quantum mechanics, it is now considered to be a very deep statement about the nature of the world. That it is never still. It is never empty. That there is no such thing as an absolute measurement of anything. Not because we interfere with it, even if we were all God forbid, extinguished by a comet hitting the Earth, it would still be the case that the quantum vacuum would be fluctuating, would be boiling with particles and antiparticles popping into and out of existence on minute time frames.
Get your last question because we're running late. Go.
Okay. I very much appreciate the overall plausibility that you've given to the sophistic line.
Right.
Yet, at the same time, you've pointed out that the rationalist strand has nevertheless been an important and essential part of science.
Yes, and continues to be.
And continues to be. And it would seem that somehow a vision needs to somehow hold these two sides together.
I love it, yes.
And I wonder if you could say just a little more about that.
I think that is my, as Terry Bristol and I have been talking for days about this, unlike, here I differ from Dewey. Dewey thought that the Platonic view was simply flat out wrong and we needed to outgrow it. I think that the fact that it's persisted for 2,300 years and been held by many intelligent people suggests very strongly that we need to keep both of those views and recognize that in some sense that we cannot conceptualize well yet, they complement one another. That of course science is about the world in some sense, but we can't logically justify the claims that scientists make as being about the world. It's not merely about experience, a cute little observation of patterns in experience, but I don't believe for myself that I have yet to read any way of explaining how these two cohere, but I think that that is the correct sort of lesson to take away from this evening's lecture. I was not trying to dismiss Plato. I was trying to resurrect the sophistic position so that they are perceived to be, so to speak, on a par with one another, that there's an interplay between them, and over the centuries we have ignored the sophistic position. And that's one of the reasons why we don't know how to use knowledge. We don't have tools for using knowledge effectively. We can't answer the question, well, I know how to do X, but should I do it? Science can't tell you that because science has systematically stripped all value judgments out of doing science in order to be abstract and theoretical. So you can't find in science reasons for building atomic bombs or for doing germ warfare or for doing anything. That has to come from outside science. Well, where's it going to come from? Politics? Sure, there's got to be a better way than that. So we have paid a price for dismissing the sophists. If you take the sophists as seriously as you take Plato, then you realize, I need to spend more time trying to figure out how to act effectively in the world and not have to lurch from crisis to crisis.
All right, we gotta run. Thank you.
Thank you.